For decades, Pluto was treated as the forgotten edge of our planetary family. After its reclassification as a dwarf planet in 2006, many people imagined it as little more than a frozen object drifting through the darkness beyond Neptune. But when the New Horizons spacecraft reached Pluto in 2015, that picture changed almost instantly. Instead of a featureless ice ball, the spacecraft revealed towering mountains, enormous plains, fractured terrain, flowing glaciers, and a strange heart-shaped region unlike anything previously seen on a distant world. The most famous part of that heart is Sputnik Planitia, a gigantic basin covered largely by frozen nitrogen. But Pluto's surface is not simply frozen and motionless. Scientists discovered evidence of geological processes that have shaped the dwarf planet over enormous periods of time. Some regions appear surprisingly young, while others preserve ancient scars from impacts that occurred billions of years ago. That raises a much bigger question. How can such a small world, located billions of kilometers from the Sun, remain geologically interesting? One possible answer lies beneath the surface. Scientists have proposed that Pluto may contain a subsurface ocean. This remains a scientific hypothesis rather than a confirmed observation, but several lines of evidence make the possibility worth investigating. Pluto formed billions of years ago from material left over from the early solar system. During its formation, collisions and gravitational compression could have generated substantial internal heat. Radioactive elements inside its rocky interior may also have released heat over extremely long periods. If enough of that energy remained trapped, some portion of Pluto's internal water could potentially have avoided freezing completely. That would transform our understanding of this distant dwarf planet. Instead of a world that froze solid soon after its formation, Pluto could possess a layered interior containing rock, ice, and perhaps liquid water beneath its frozen exterior. There is no evidence that this hidden ocean contains life. But the possibility is scientifically fascinating. Earth has taught us that life can survive in environments far removed from sunlight. Deep beneath our oceans, organisms exist around hydrothermal systems and other extreme environments where sunlight plays little or no direct role. That does not mean Pluto has life. It means scientists have learned that habitability can be more complicated than simply measuring the temperature at a planet's surface. Pluto's largest moon, Charon, adds another layer to the mystery. Unlike most planet-moon systems, Pluto and Charon are so closely connected that both bodies orbit a shared point located outside Pluto's center. Their gravitational relationship has influenced their histories, while the enormous impact that may have created the system could also have affected Pluto's internal structure. Pluto's atmosphere is another surprise. Although extremely thin, it is not completely static. It contains mostly nitrogen along with smaller amounts of methane and carbon monoxide. As Pluto travels around the Sun, changes in sunlight can cause surface ices to evaporate and later condense again. This creates a seasonal cycle unlike anything experienced on Earth. Even the reddish color visible across parts of Pluto has an intriguing explanation. Solar ultraviolet radiation and energetic particles can interact with molecules in Pluto's atmosphere and surface ices, producing complex organic compounds known as tholins. These materials can give the surface its distinctive reddish-brown appearance. They are not proof of life, but they demonstrate that complex carbon chemistry can develop in an environment extremely far from the Sun. And that is perhaps the most important lesson Pluto has given us. A world does not need to resemble Earth to be scientifically fascinating. It does not need forests, blue skies, or oceans visible from space. It can be dark, frozen, distant, and still possess a complex geological and chemical history. New Horizons only spent a short time studying Pluto during its historic flyby. That brief encounter transformed our understanding of the dwarf planet, but it also left enormous unanswered questions. What lies beneath Sputnik Planitia? How deep might Pluto's internal layers extend? Could liquid water still exist somewhere below the ice? And how did such a distant world develop such an active and varied surface? To answer those questions, scientists will eventually need another mission. And that mission could reveal a Pluto even stranger than the one New Horizons discovered. Pluto may be small, distant, and incredibly cold, but the more scientists study it, the harder it becomes to describe as a simple frozen object. Its surface tells the story of a world that has experienced dramatic changes. Its atmosphere responds to seasonal variations. Its glaciers move. Its mountains rise thousands of meters above the surrounding terrain. And beneath all of that, there may be an ocean hidden under layers of ice. But there is still a major problem. We have only visited Pluto once. The New Horizons spacecraft raced through the system in 2015, collecting an extraordinary amount of information during its brief encounter. It transformed Pluto from a tiny point of light into a real world. Yet a flyby can only reveal so much. A future spacecraft could spend much longer studying the dwarf planet, mapping its surface in greater detail and measuring changes across its atmosphere and terrain. An orbiter would be especially valuable. Instead of passing Pluto once, an orbiter could repeatedly examine the same regions, monitor seasonal changes, study atmospheric behavior, and investigate the gravitational properties of the dwarf planet. Those measurements could help scientists understand what is happening below the surface. One of the biggest mysteries is the proposed underground ocean. Scientists cannot currently see this ocean directly. Instead, they examined Pluto's shape, surface structures, thermal history, and geological features to determine whether an internal ocean is physically plausible. If such an ocean exists, it could be buried beneath a massive layer of ice. The pressure at those depths would be enormous, and the water might behave very differently from the oceans on Earth. There could also be exotic forms of ice created by extreme pressure. In other words, Pluto's interior may be far more complicated than its frozen exterior suggests. But what about life? This is where speculation must be separated from evidence. No spacecraft has discovered living organisms on Pluto. The James Webb Space Telescope has not detected alien life there. JWST can contribute to the study of distant objects and atmospheric chemistry, but it cannot directly see organisms beneath Pluto's surface from Earth. At present, the idea of life on Pluto remains hypothetical. Still, the possibility is scientifically interesting because Pluto expands our understanding of where potentially habitable environments might exist. If liquid water can survive beneath the surface of a distant icy world, then similar environments could potentially exist elsewhere in the outer solar system. That brings Pluto into a much larger story. Beyond Neptune lies the Kuiper Belt, a vast region containing countless icy bodies left over from the formation of the solar system. Pluto is one of its largest known members. If Pluto possesses a complex interior, other distant worlds could potentially have their own hidden geological histories. Some might contain oceans. Others could preserve ancient chemistry from the birth of the solar system. And some may have characteristics that scientists have not yet imagined. This is why Pluto matters. It is not simply about whether Pluto has an ocean. It is about what Pluto teaches us about planetary evolution. For a long time, scientists assumed that small bodies far from the Sun would quickly become frozen and inactive. Pluto challenged that assumption. Its enormous glaciers demonstrate that ice can flow. Its mountains reveal a complicated geological past. Its atmosphere changes with the seasons. Its surface contains complex organic compounds. And its possible internal ocean suggests that even the most distant worlds may retain heat and geological activity long after their formation. The next chapter of Pluto's story will probably require another spacecraft. A mission capable of orbiting the dwarf planet could search for evidence of internal activity, investigate its atmosphere, map its surface, and perhaps determine whether a hidden ocean is actually present. It could also examine Charon and the smaller moons, revealing how this unusual system formed and evolved. Until then, Pluto remains a mystery. Not a dead world. Not an alien civilization. Not proof of extraterrestrial life. But something more scientifically valuable, an unfinished story. A tiny world at the edge of the solar system that has already forced us to reconsider what a planet can be. And perhaps that is Pluto's greatest secret. The farther we travel from the Sun, the more unexpected the solar system becomes. Beyond the familiar planets lies an enormous frontier filled with ice, darkness, chemistry, and worlds we have barely begun to understand. Pluto was once considered the end of the planetary story. Now it looks more like an invitation to continue exploring.